Hi students, this is Anoop with you. Thanks for reaching my channel. Today we will be doing MCQ questions from the topic Relations and Functions. At the end of the video, there will be a question of the day. The names of the first 3 people to send the correct answer will be mentioned in the next video. After 10 such videos, whoever comes maximum number of times in the first 3 positions will be the final winner and will receive a prize. This is to encourage competitive spirit among the students. Send the answer to that question to the email mathswithanoop@gmail.com. So stay tuned, watch till end of the video. We will move to our first MCQ question today. It is a 2005 AIEEE question. Let R equal set ordered pair 1, 3, 4, 2, 2, 4, 2, 3, 3, 1 be a relation on set A equals set 1, 2, 3, 4. The relation R is. They are asking whether this relation is a function or whether it is a transitive relation or whether it is not a symmetric relation or whether it is a reflexive relation. So I am checking whether it is a function or not first of all. 1, 3, 4, 2, 2, 4, 2, 3. See, 2 has more than one image. 2 has an image 4 and 2 has another image 3. For being a function, every element should have a unique image. It should not have more than one image. Here the element 2 is having more than one image, so it is not a function. So the option C is not valid. It is not a function. Now I am checking which kind of relation it is. First I will check whether it is a reflexive relation or not. For being reflexive relation, this A comma A should be an element of this relation. I am checking. 1 comma 1 doesn't belong to R. So you can say it is not a reflexive relation. If 1 comma 1 was there, will it be a reflexive relation? No. Then 2 comma 2 also should be there and 3 comma 3 also should be there. 4 comma 4 also should be there. If one of those elements is not there, then it will not be a reflexive relation. For being reflexive relation, A comma A should be belonging to this relation set for every A. Not only for one element, for all these elements, there should be a pair of A comma A. So it is not a reflexive relation you got. Now I am checking whether it is symmetric or not. What is the condition of a symmetric relation? If A comma B is belonging to R, this should imply B comma A also an element of R. I am checking whether it is satisfying for these elements. 1 comma 3 belongs to R. 3 comma 1 also belonging to R. So it satisfies. 4 comma 2 belongs to R. 2 comma 4 also belonging to R. So that also satisfies. But next element 2 comma 3 is an element of R. But 3 comma 2 is not an element of R. It is not there in this set. Therefore, it is not symmetric. So we got already the answer C, not symmetric. C is our answer. Now still we will check whether it is a transitive relation or not. For being transitive relation, what is the condition? If AB is an element of R and BC is an element of R, this should imply A comma C is an element of R. This A and C should be related. So 1, 3 belongs to R. 1, 3 is an element of R and 3, 1 is an element of R. See, it is given 3, 1 is an element of R. But this A and C, 1 comma 1 doesn't belong to R. Therefore, it is not a transitive relation. So we got this relation is not a function and this is not a reflexive relation, not a symmetric relation, not a transitive relation. So which is our option? our option satisfying this condition is option C. It is not symmetric relation. Now moving to next MCQ question. Which of the following relations on R is an equivalence relation? What is an equivalence relation means? It should be reflexive relation, symmetric relation and transitive relation. If all these three conditions are satisfying, that function we can call it as an equivalence relation. So I am checking the first given option. A R1B means A related to B. R1 is the relation name such that mod A equal to mod B. Checking whether it is reflexive. To be reflexive, A comma A should be belonging to this relation. So A comma A should be an element of R1. So I am substituting A and B both as A and A. So what I will get? Mod A equals mod A, which is true. Therefore, it is reflexive relation you are getting. Now I am checking whether it is symmetric or not. What is the condition for symmetric? If A comma B belongs to R, here R1 is the name of the relation, then B comma A should also be an element of this R1. I am checking mod A comma B belongs to R1 means mod A equal to mod B. From here I am getting. From this I can write, if mod A is mod B, I can write mod B also equal to mod A. If mod B is mod A, then B is related to A. So from here I can write B comma A belongs to this relation set R1. Therefore, it is symmetric. Now I have to check whether the given relation is transitive or not. We got reflexive and symmetric. If it is also transitive, then we can tell this option A is an equivalence relation. For being transitive, what is the condition? AB should belong to R and BC should be there in R. Then you have to check whether AC is there in R or not. If AC is also element of this R, then it is called a transitive relation. So I am checking AB belongs to R means what? This implies mod A equal to mod B. BC belongs to R means mod B equal to mod C. If mod A is mod B and mod B is mod C, from this equation 1 and 2 you can clearly say mod A equal to mod C. Therefore, A comma C is an element of this relation. Here relation name is R1. Here R1, R1. So, this is a transitive relation. Since it is reflexive, symmetric and transitive, this is an equivalence relation. So, option A is our answer. So, we already got the answer in the A itself. Now, moving to B, we are just checking whether it is reflexive or not. A comma A, then A greater than or equal to A. It is true. A can be greater than or equal to A. So, it is reflexive. But for symmetric, if A is greater than or equal to B, not necessary that B will be greater than or equal to A. 4 greater than or equal to 2. But 2 is not greater than or equal to 4. So, it is not symmetric. So, it is not an equivalence relation. Now next one, A divides B. We are checking whether it is a reflexive relation. A divides A. So A comma A is belonging to R3. It is an element of R3. So it is reflexive relation. Now checking for the symmetric part. A divides B. But it doesn't mean that B divides A. So it is not symmetric. Therefore it is not an equivalence relation. Now next one, A less than B. I am checking A comma A belonging to R or not. Then you will get A less than A, which is not true. A cannot be less than A. Therefore, it is not reflexive. Therefore, it is not an equivalence relation. So our answer is option A. Now we will see another MCQ question. Let R be the real line. Consider the following subsets of the plane R cross R such that S equal to x comma y such that y equal to x plus 1 and 0 less than x less than 2. And another set T is given, set ordered pair x comma y such that x minus y is an integer. Which of the following is true? Different options are given. They are asking which one is equivalence relation. Are both of this equivalence relation or any one of them is equivalence relation? So I am taking the first set. S equal to set ordered pair x comma y such that y equal to x plus 1. X and y are real numbers and x is between 0 and 2. Y equals x plus 1. Checking whether it is reflexive, symmetric and transitive. If all these three conditions are satisfying, then it will be an equivalence relation. First I am checking it is reflexive or not. To be reflexive, x comma x should belong to the relation set. I am checking x and y, both I am putting as x. So x equal to x plus 1, which is not true. So you can understand that it is not reflexive. If it is not reflexive, no need to check whether it is symmetric or transitive, because if it is not reflexive, it is not an equivalence relation. Question is to check whether it is equivalence relation or not. Not equivalence relation. So which first S you got, it is not an equivalence relation. Now we will check the next relation T, whether it is equivalence relation. So first I am checking whether this T is reflexive or not. So to be reflexive, x comma x should belong to this relation. Name of the relation is T, so I am mentioning T. So x and y I need to substitute as x. So it will become x minus x, which is equal to 0, because here relation is x minus y is an integer. I substituted x and y as x itself. So x minus x equal to 0, which is an integer. This is true, because 0 is an integer. So I got x comma x belonging to this relation T, therefore it is reflexive. Now I need to check whether it is symmetric. For being symmetric, if xy is belonging to this relation T, then y comma x also should be belonging to the relation T. If x minus y, x comma y belongs to T means x minus y is an integer. If x minus y is an integer, you name it as A. Y minus x will be what? Minus A. This is also integer. If A is an integer, minus A also will be an integer. So you can tell y comma x is an element of the relation T. Therefore, you got this is symmetric. This relation T is symmetric. Now I need to check whether it is transitive. Now we got the relation T is reflexive and symmetric. Now I am checking whether it is transitive or not. For being transitive, xy should be an element of T and yz is an element of T. Then this should imply x comma z is an element of T. If x comma y is an element of T, x minus y is an integer. That is the relation. So x minus y is an integer. I am assuming it as A. Now y comma z belongs to T means y minus z is an integer. I am assuming it as some other integer B. Now I need to prove x minus z is an integer. I am adding both these equations. X minus y plus y minus z equals RHS adding a plus b. Cancelling this y, I got x minus z equals a plus b. We know a and b are integer. So x minus z equal to a plus b also an integer. So you can understand x comma z is belonging to this relation T. Therefore, it is transitive relation. Since we proved T is reflexive, symmetric and transitive, you can say T is an equivalence relation. At the same time, we got S is not an equivalence relation. So our option A is the correct answer. T is an equivalence relation, but S is not an equivalence relation. Now we will proceed to another MCQ question. Let P equal to set x comma y such that x square plus y square equal to 1. X comma y is an element of real number. Then P is reflexive relation, symmetric relation, transitive relation, or not symmetric relation. So I am checking whether it is reflexive or not. To prove reflexive, you need to prove x comma x is belonging to this relation. I am checking this, whether x comma x is an element of R. X comma y means x square plus y square equal to 1. So x comma x means x square plus x square. Replace y with the x equals 1. 2x square equal to 1. It is not always true. If x is plus or minus 1 by root 2 only, it will be true. But for all the elements, x comma x should be belonging to this relation set. So you can clearly tell that this is not a reflexive relation. Now I am checking whether it is symmetric or not. For checking symmetric, x comma y is an element of R. You need to see whether y comma x is an element of R. X comma y is an element of R means it is given in the question x square plus y square equal to 1. If x square plus y square is 1, I can write y square plus x square also as 1. That means y comma x is an element of R. See, y square plus x square equal to 1. I can write it as y comma x belongs to R. So you can see that this is a symmetric relation. It is not reflexive, but we got it as symmetric relation. Now checking for transitive. X comma y belongs to R and y comma z belongs to R. You need to see whether x comma z is element of R or not. This will give you x square plus y square equal to 1. From here you will get y square plus z square equal to 1. You need to see whether x square plus z square equal to 1. Clearly from these two you can understand that x square plus z square will not be equal to 1. So it is not a transitive relation. So our answer is, it is symmetric relation, option B. Now we will see another MCQ question. Let R equal set x comma y such that x comma y is an element of A, x plus y equal to 5, where A equals set 1, 2, 3, 4, 5. Then they are asking which kind of relation is this. So first I will write it down in roster form. It is given in set builder form. I am going to write this relation in roster form. X and y should belong to this A. So I am taking x as 1. If x is 1, y will be 5 minus 1, 4. Now I am taking x as 2 from this A. If x is 2, y will be 5 minus 2, 3. Now taking x as 3, if x is 3, y will be 5 minus 3, 2. Then x is 4, 5 minus 4, 1 will be the value of y. Now if x is 5, y will be 0, which is not possible. They told x comma y should be an element of A. So if I put x as 5, y will be 0, which is not an element of A. So I have to stop here. Now I can check whether it is reflexive, symmetric or transitive. Checking for the reflexive condition, x comma x should be belonging to A. 1 comma 1 is not element of this relation, so not reflexive. Now checking for symmetric, 1, 4 belongs to R, 4, 1 also belonging to R. If AB is belonging to R, B comma A should be an element of R, then it is reflexive. For 1, 4 it is satisfying that condition. Now checking for next element, 2, 3. 3, 2 also there in relation. So this satisfies the condition of symmetric. So it is a symmetric relation. Because 1, 4 is there in R and 4, 1 also there in R. And 2, 3 is there in R and 3 comma 2 also there in R, so it is symmetric relation. Now checking for the condition of transitive. 1 4 is there in R and 4 1 is also an element of R. Then to be transitive, this x comma z means 1 comma 1 should be there in R. I am checking 1 comma 1 is not an element of R. So it is not a transitive relation. So what we got? It is only symmetric, not reflexive and not transitive. So our answer is option C. R is not reflexive, not transitive, but it is symmetric relation. Now we will see another MCQ question. R is a relation over set of integers and is given by x comma y belonging to relation which is modulus x minus y less than or equal to 1. Then R is, they are asking it is which kind of relation. So I am writing modulus x minus y less than or equal to 1. This is the relation given. First I am checking whether it is reflexive or not. To be reflexive, x comma x should belong to R. I am checking whether it is true. I will get modulus x minus x. X comma x means modulus x minus x less than or equal to 1, which is 0 less than or equal to 1, true. That means it is a reflexive relation. Now I have to check whether it is a symmetric relation or not. Mod x minus y less than or equal to 1. So modulus y minus x also will be less than or equal to 1. I can take negative out. Minus of y minus x less than or equal to 1. Modulus negative of y minus x means I can write it as simply y minus x less than or equal to 1. Therefore, y comma x is an element of R. Therefore, it is symmetric relation. Now I need to see whether this is a transitive relation or not. For that I am taking an example. 1 comma 2 is an element of this relation because modulus 1 minus 2 is modulus 1 which is less than or equal to 1. You are getting mod 1 which is less than or equal to 1, true. Now I am taking 2 3. 2 3 is an element of R because modulus 2 minus 3 is less than or equal to 1. Because modulus 2 minus 3 is 1, less than or equal to 1. This is also true. Now I am checking whether this x comma z 1 comma 3 is belonging to R or not. If 1 3 is an element of R, then we can say that it is transitive. I am checking modulus 1 minus 3 less than or equal to 1. Mod 1 minus 3 is 2 is less than or equal to 1 is not true. That means 1 comma 3 doesn't belong to R. So it is not transitive. So you got it as reflexive and symmetric relation, but it is not a transitive relation. For disproving, one example is enough. But proving it should be generally true for all the elements of that set. But for proving that it is not transitive, one example is enough. So we understood it is reflexive and symmetric but not transitive. So our option A is the correct answer. Now we will see another MCQ. On the set n of all natural numbers, define the relation R by A related to B if IFF means if and only if. If and only if the GCD of, GCD means greatest common divisor of A and B is 2. Then R is which kind of relation they are asking. First I will check whether it is reflexive or not. To be reflexive, A comma A should be an element of R. A comma A means, what is A comma B means? GCD of A and B. So A comma A element of R means GCD of A and A is 2. GCD of A and B is 2 given. So A comma A means GCD of A and A should be 2. Which is wrong. Greatest common divisor of A and A is the same number itself, A. So you can understand that it is not a reflexive relation. Now checking for symmetric. GCD of A and B is same as GCD of B and A. If you take, for example, GCD of 2 and 4 is 2. GCD of 4 and 2 also will be 2. So it is symmetric relation. So you got, it is not reflexive but it is symmetric. Now I am checking for transitive. To be transitive, AB there in R and BC is there in R, then you have to prove A comma C is available in relation set or not. To check whether it is transitive or not, I am taking an example. 4 comma 6 is an element of R. GCD of 4 and 6 is what? Greatest common divisor of 4 and 6 is 2. So 4 comma 6 is belonging to R. Now I am taking 6 comma 8 is an element of R or not, I am checking. GCD of 6 and 8, greatest common divisor of 6 and 8 is 2. Now check whether this 4 comma 8 is an element of R or not. If it is an element, it will be transitive relation. I am taking 4 comma 8 is an element of R or not. So GCD of 4 and 8 is not 2. GCD of 4 and 8 is 4. Greatest common divisor of 4 and 8 is 4. So 4 comma 8 is not an element of R. So it is not transitive. So you got it as not reflexive, not transitive, but it is symmetric relation. So our answer is option B. This relation is symmetric only. Now we will move to another question. If for x comma y belonging to R, define a relation R by x related to y if and only if x minus y plus root 2 is an irrational number, then R is which kind of relation they are asking. So I am checking whether it is reflexive or not. X comma x belongs to R. I am checking whether it is true. So when I substitute y also as x, it will become x minus x plus root 2. So I will get root 2, which is an irrational number. So x comma x belonging to R is true. Therefore, this is a reflexive relation. I am taking an example. Root 2 comma 1 is an element of R. So when I substitute x as root 2 and y as 1, I will be getting root 2 minus 1 plus root 2 equals 2 root 2 minus 1 is an irrational number. So root 2 comma 1 is an element of R. Now I need to check 1 comma root 2 is an element of R or not. If 1 comma root 2 is also an element of R, then it is symmetric relation. 1 comma root 2 means x I am substituting 1, y as root 2. 1 minus root 2 plus root 2. I got 1, which is not irrational number. So I am getting 1 comma root 2 is not an element of R. Therefore, it is not symmetric. Now I have to see whether it is a transitive relation or not. For that, I am taking an example. Root 2 comma 1 belongs to R, which is root 2 minus 1 plus root 2. We saw just now 2 root 2 minus 1 is irrational. Now 1 comma some other number, I am taking 1 comma 2 root 2. So it will become x as 1 and y as 2 root 2. 1 minus 2 root 2 plus root 2. I will get 1 minus root 2, which is also irrational number. Now I need to see whether root 2 comma 2 root 2 is an element of R. I am checking root 2 comma 2 root 2 is an element of R or not. Substitute x as root 2 and y as 2 root 2. So it will become root 2 minus 2 root 2 plus root 2. I will get 2 root 2 minus 2 root 2, 0, which is not an irrational number. So I am getting root 2 comma 2 root 2 is not an element of R. Root 2 comma 1 is an element of R. 1 comma 2 root 2 is an element of R. But this root 2 comma 2 root 2 is not an element of R. So I am getting this is not a not transitive relation. So we got this as only reflexive. So our answer only reflexive, not there in any of the option. So our answer is option D, none of these. Now next question, given a relation R equals set ordered pair 1 comma 2 ordered pair 2 comma 3 in the set A equals set 1 2 3. The minimum number of ordered pairs which when added to this R make it an equivalence relation is. Options are given. So here question is one relation R is given as 1, 2 and 2, 3. They are asking how many minimum number of ordered pairs should be added to this so that it will be an equivalence relation. So first we will try to make it a reflexive relation. To make it reflexive, definitely there should be 1, 1 and 2, 2, 3, 3. These three elements should be there in this relation, then only it will be reflexive. Now it is a reflexive relation. Now to check whether it is symmetric, 1, 2 is already there. Then you need to add 2, 1. A, B belongs to R, B, A should also be belonging to R to make it symmetric. 2, 3 is already there. I need to add 3, 2 to make it symmetric. Now this relation is reflexive and symmetric. Now I am checking whether it is transitive or not. To make it transitive, I am checking what all elements should be added. I need to add 1, 3 and 3, 1 to this to make it transitive. 1, 2 belongs to R and 2, 3 belongs to R. 1, 3 is there in R. 1, 3 is an element of R. 3, 1 also element of R. Therefore, 1, 1 is an element of R. So, this will be reflexive, symmetric and transitive. So, how many ordered pair you have added to this to make it an equivalence relation? These many. 1, 2, 3, 4, 5, 6, 7 ordered pairs you have added to this. So, our answer is option C, 7. Now we will move to another question. Let R equal set 3, 3, 6, 6, 9, 9, 12, 12, 6, 12, 3, 9, 3, 12, 6, 3, 6 be a relation on set A equals set 3, 6, 9, 12. The relation is, they are asking whether it is only reflexive relation or it is reflexive and transitive or it is reflexive and symmetric or it is an equivalence relation. First, we will check whether it is a reflexive relation or not. All these elements, check whether everything element is related to itself or not. 3, 3, it is an element of R. 6, 6 also there, it is an element of R. 9, 9, it is there, it is an element of R. 12, 12, that is also an element of R. So clearly you can say this relation is a reflexive relation. Now checking for symmetric. If AB is belonging to R, B also A should belong to R. So I am checking 6, 12 belongs to R. But 12, 6 is not an element of R. See, 6, 12 is there in this relation, but 12, 6 is not there in this relation. So you can clearly say it is not symmetric. So we got it is a reflexive relation, but it is not a symmetric relation. Now we will see whether it is a transitive relation or not. 3, 6 belongs to R. And 6, 12 also an element of R. Check whether 3, 12 is there in R or not. 3, 12 is also an element of R. So this is a transitive relation. So you got this relation is a reflexive relation and it is a transitive relation, but it is not symmetric. So option B, it is reflexive and transitive only. This is the option satisfying the condition. So option B is our correct answer for this. Now moving to next MCQ. This is an AIEEE 2006 question. The previous question what we discussed also is an old AIEEE question. Let W denote the words in English dictionary. Define the relation R by R equals set X comma Y such that W cross W. The words X and Y have at least one letter in common. Then the relation R is. They are asking which kind of relation will be this. The relation is that the words X and Y have at least one letter in common. So I am checking first whether it is a reflexive relation or not. To be reflexive relation, X comma X should be an element of this R. So considering the relation, the words X and instead of Y, you have to mention X. X and X have at least one letter common. Yes, same word and itself has all the letters in common. So this condition satisfied. They have at least one letter in common. So it is reflexive. Is this clear? One word. Suppose I am taking the word next. This has four letters N-E-X-T. Another word is this word itself N-E-X-T. Both of these words, the next and again considering the same word next, they have at least one letter common. Actually all letters are common between them. So X comma X is an element of R. It is clearly a reflexive relation. Now going to check whether it is symmetric or not. For being symmetric, X comma Y belongs to R should imply Y comma X is also an element of R. So I am taking an example. And one word and, second word next. Do they have any letter in common? At least one letter in common? Yes. N is common in both of them. So and next has letter N common. So X comma Y is an element of R. Now I am taking the reverse. Do next and the word and, they have any letter in common? Yes, they have N common. So Y comma X also an element of R. If X comma Y is belonging to R and you are getting Y comma X also an element of R, then it is symmetric relation. So clearly you can say this is a symmetric relation. Now going to check whether it is transitive or not. For being transitive, if X comma Y belongs to R and Y comma Z belongs to R, you have to check whether this X comma Z is an element of R or not. So I am taking X as the first word and Y I am taking the word next. Z I am considering the word here. Now I am checking whether X comma Y belonging to R or not. Means this and word and the next word, do they have any letter common? Yes, they have N common. So this condition is okay. Now I am checking Y comma Z is an element of R or not. Means the word next and the word here, do they have at least one letter in common? Yes, they have letter E in common. So this condition is okay. Now I have to check whether this X comma Z is an element of R. Means the word and the word here, I have to check whether they have at least one letter common or not. I am checking and here. They have no letter in common. So X comma Z belonging to R is wrong. X comma Z is not belonging to R. It is not an element of R. Therefore, it is not transitive relation. So we got this relation as reflexive and symmetric, but it is not transitive relation. So it is matching with our option B. Now we will see another MCQ. R is a relation over the set of real numbers and it is given by Mn greater than or equal to 0. Then R is. Which kind of relation it is they are asking. So M related to N given as Mn greater than or equal to 0. So I am checking for reflexive. Means checking M comma M is an element of R or M related to M or not. M related to M means M into M, M square greater than or equal to 0. Which is true. Square of a number is greater than or equal to 0. Now checking for symmetric. M related to N is given Mn greater than or equal to 0. If Mn is greater than or equal to 0, you can write Nm greater than or equal to 0. This means N is related to M or N comma M is an element of R. M related to N is Mn greater than or equal to 0. So Nm greater than or equal to 0 means N related to M. So you are getting it as symmetric relation. Now I am checking for transitive relation. M related to N and N related to P. You have to check whether this M is related to P or not. M related to P we are checking. M related to N means Mn greater than or equal to 0. N related to P means Np greater than or equal to 0. So if both are positive or both are negative only, this condition will satisfy. Here also, if both are positive or both are negative only, this condition will satisfy. That means M, N and P have same sign. So you can clearly write MP will be greater than or equal to 0 because M and P has same sign. Positive into positive or negative into negative, it will be greater than or equal to 0. Therefore, you are getting M is related to P. Therefore, it is a transitive relation. Since it is reflexive, symmetric and transitive, our answer is option C, an equivalence relation. Now we will move to another question. Let A equal set 1, 2, 3. The relation R equals set ordered pair 2, 3 in A is. They are asking this relation is which kind of relation? Clearly you can say this is not reflexive as 1, 1 is not there. Even 2, 2 and 3, 3, none of these are available in that. So it is not a reflexive relation. Now checking symmetric. 2, 3 is belonging to R, but 3, 2 doesn't belong to R. Therefore you can say it is not symmetric relation. Now we will see whether this relation is transitive or not. What is transitive relation? If A, B belongs to R and B, C belongs to R, and if you are getting A, C is not element of R, then it is not transitive. And if you are getting A, C belongs to R, it is an element of R, then it is transitive. Suppose you have only this and you don't have this pair available, then also it is called transitive relation, because you are not able to prove that it is not transitive. In that case, it is called transitive relation. Here 2, 3 is element of R, but 3, Y is not element of R. If 3, Y is an element of R only, you have to check whether 2, Y is there or not. Otherwise, if this pair is not available, you can say it is transitive relation. So our answer is option B, transitive only. Now we will move to another MCQ question. Let a relation R in the set of natural numbers defined by x, y is an element of R, implies x square minus 4xy plus 3y square equal to 0. This is the relation given. For all x comma y in set of natural numbers, then the relation R is. They are asking which kind of relation is this. So first I am checking, you need to check whether x comma x is an element of R or not. X comma y means this. So x comma x means replace y with x. You will get x square minus 4x into x, 4x square plus 3x square. Instead of y you have to substitute x. So 4x square minus 4x square, it is giving you 0. So x comma x is an element of R, therefore this relation is reflexive. Now we will check whether this is a symmetric relation or not. I am taking an example. 3, 1 belongs to R. I am checking whether 3, 1 is belonging to R. 3 square minus 4 into 3 into 1. Putting x as 3 and y as 1. Plus 3 into y square, 3 into 1. So 9 minus 12 plus 3. So 12 minus 12, 0. You are getting 0. So 3 comma 1 is an element of R. Now I am checking whether 1 comma 3 is an element of R or not. If you are getting 1 comma 3 an element of R, then it will be symmetric. If you are getting 1 comma 3 is not an element of R, then it is not a symmetric relation. So substitute x as 1 and y as 3. So 1 minus 4 into 1 into 3. 4 into 1 into 3. Plus 3 into y square. 3 into 3 square 9. So 1 minus 12 plus 27. This is not equal to 0. Means 1 comma 3 is not an element of R. Therefore it is not a symmetric relation. So you got this as reflexive and it is not a symmetric relation. Now I am checking whether this is a transitive relation or not. I am taking an example. 9, 3 is an element of R. I am checking. 9, 3 means substitute x as 9, y as 3. So 9 square minus 4 into 9 into 3 plus 3 into 3 square. 81 minus 4 into 3, 12 into 9, 108 plus 3 into 3 square, 3 into 9, 27. So you'll get 81 plus 27, 108 minus 108, 0. So 9, 3 is an element of R. And 3 comma 1 is an element of R. We are checking. Already we checked here and we got it 0. So 3, 1 is an element of R. Now I need to see whether 9 comma 1 is an element of R or not. If 9 comma 1 is an element of R, then it is transitive relation, and if it is not an element of R, then it is not a transitive relation. Substitute x as 9 and y as 1. So 9 square minus 4 into 9 into 1 plus 3 into 1 square. 81 minus 36 plus 3. This is not equal to 0. That means 9 comma 1 is not an element of R. That means it is not a transitive relation. So you got it is reflexive but not symmetric, not transitive. So our answer is option A, reflexive. Now moving to another question. Let S be the set of real numbers. Then the relation R equal to set ordered pair A comma B such that 1 plus AB greater than 0 on S. S means set of real numbers is. They are asking which kind of relation is this. So I am checking whether it is reflexive first of all. Reflexive condition is A comma A should belong to this relation R. So I am checking whether A is related to A or not. A comma A means 1 plus A into A. B I have to substitute as A. 1 plus A square greater than 0. Which is true. 1 is positive and square of a number also positive. So this will be greater than 0. Now I have to check whether it is symmetric or not. AB belongs to R. It is given in the question. The condition is that 1 plus AB greater than 0. If 1 plus AB is greater than 0, I can write 1 plus BA greater than 0. That means B comma A is an element of R. 1 plus BA greater than 0 means B comma A is an element of R. So it is symmetric relation. We got it, reflexive and symmetric. Now I need to check whether it is transitive or not. I am taking an example. 6, 3 belongs to R. Because 1 plus 6 into 3 is greater than 0. Then 3 comma minus 1 by 5 I am taking whether it is an element of R. 1 plus 3 into minus 1 by 5, which is 5 minus 3 by 5, which is greater than 0. So this is also true. Now I need to check whether this 6 comma minus 1 by 5 is an element of R or not. If it is an element of R, then it is transitive. If it is not an element of R, it will not be transitive. So I am taking 6 comma minus 1 by 5 is an element of R or not. So 1 plus 6 into minus 1 by 5, which is 5 minus 6 divided by 5, which is minus 1 by 5. It is not greater than 0, it is less than 0. That means 6 comma minus 1 by 5 is not an element of R. Therefore, it is not a transitive relation. So what you got? It is reflexive and symmetric but not transitive. So our answer is option A, reflexive and symmetric but not transitive. Now moving to next question, a function f from n to z from natural number to integers defined by f of n equal to n minus 1 by 2 if n is odd and the function's value is minus n by 2 if n is even. They are asking it is which kind of function, 1 1 or on to or both 1 to 1 and on to. So I am checking for 1 to 1 first of all. 1 to 1 means if f of n1 equal to f of n2, this gives you n1 equal to n2, then it is 1 to 1 function. So I am taking the case 1 as if n1 and n2 are even, both are even numbers. Means n1 even number means it can be written as 2m1 because 2 times some number is even number, and n2 you can write as 2m2. So f of n1 equal to f of n2 means f of 2m1 equals f of 2m2. Substituting here, f of n is minus n by 2. So f of 2m1 means minus 2m1 by 2 equals minus 2m2 by 2. Cancelling this, from here you are getting m1 equal to m2. Means n1 will be equal to n2. Now I am taking case 2. Means if n1 and n2 are odd. If n1 and n2 are odd, means n1 you can write 2m1 plus 1. This is the representation of an odd number. n2 I can write 2m2 plus 1. So f of n1 equals f of n2. Means f of n1 means 2m1 plus 1. It is odd, so I have to substitute it here. So f of n1 means 2m1 plus 1 minus 1 by 2 equals f of n2 means n2 is 2m2 plus 1, substitute n as 2m2 plus 1. So 2m2 plus 1 minus 1 by 2. Cancelling this, cancelling plus 1 and minus 1, cancelling this 2 and 2, then cancelling this 2 and 2. So you will get m1 equal to m2. Means 2m1 plus 1 and 2m2 plus 1 are equal. Means n1 equal to n2. Therefore, you can conclude that it is 1 to 1 function. You need to find out case 1 and case 2. From both case you are concluding it is 1, 1. Then only you can tell that this function is 1-to-1 function. If case 2 is not valid, you cannot tell it is 1-to-1 function. Because both should be valid. If n1 and n2 are even, or if n1 and n2 are odd, in both the cases you should be able to prove it is 1-to-1 function. Now checking for onto, whether this is an onto function or not. So I am substituting f of 1. 1 is odd number, I have to put it here. 1 minus 1 by 2, 0. For onto means for all the y values which is belonging to z, there should be a corresponding value of x belonging to this natural number. So for y equals 0, there is a corresponding value of x which is 1 is belonging to n. Now I am taking f of 2. 2 is even number, so I have to put it here. Minus 2 by 2, which is minus 1. For y equal to minus 1 is an integer. There is a corresponding value of x, which is 2, belonging to its domain. Same way, if you take any y values, there will be a corresponding value of x in its domain. So you can conclude that it is onto. So you proved it is 1, 1. So you have seen now it is 1-to-1 function and it is onto function. So our answer is both 1-to-1 and onto, option B. Now we will see another MCQ. Let A and B are two finite sets having m and n elements respectively. If m less than or equal to n, the total number of injective functions from A to B is. It is given number of elements in A is less than or equal to number of elements in B. In that case, number of injective functions from A to B is n, p, m. This is already explained in my shortcuts in Relations and Functions video. npm equals n factorial by n minus m factorial. So our answer is option D. Now next question, which of the following functions from I to itself is a bijection? Bijection means it should be 1-to-1 function and onto function. Then only you can call it as bijective function. So it is function is defined from I to itself. I means integer. Now commonly z is used for denoting the integer. Here letter I is used. So it is from I to I, means integer to integer. So I am taking the first function f of x equal to x cube, checking whether it is 1-to-1 or not. For that, f of x1 equal to f of x2, means x1 cube equals x2 cube. From here you can write x1 equal to x2. Therefore it is 1-to-1 function. Now checking for onto. For finding onto, I need to write y equal to x cube. From here x equals y to the power 1 by 3. Now for all values of y which is belonging to the integer set, I should get a value of x which is belonging to integer set. If for any one value, if it is not satisfying, it will not be an onto function. I am taking y as 2. This is not belonging to the integer set. So it is not an onto function. So they are asking which is bijection. So option A is removed because it is not onto. Now taking second option, f of x equals x plus 2. So f of x1 equal to f of x2, I am writing 2x1 plus 2 equals 2x2 plus 2. Cancelling the 2 and then again cancelling this 2. So you will get x1 equal to x2. So it is 1-to-1 function. Now checking for onto, I need to write y equals x plus 2. From here I will get x equals y minus 2. Now see, whatever you put for y, 0, 1, 2, 3, negative 1, anything which is an integer, you will get an value for x which is also belonging to integer. Therefore, it is an onto function. Y, for any value of y belonging to integer, you will get a corresponding value of x which is also belonging to integer. So it satisfies the condition of onto function. So second option B is our answer, which is bijective. Option B is bijective. Still we will see this, checking whether it is 1 to 1. 2x1 plus 1 equal to 2x2 plus 1. You will get x1 equal to x2 from that. It is 1 to 1. But for onto, y equals 2x plus 1, which will give you x equals y minus 1 by 2. If I put y as 2, for y equal to 2, x will be what? 2 minus 1 by 2, 1 by 2. This is not belonging to integer. So it is not onto, hence it is not a bijective mapping. Next one, x1 square plus x1 equal to x2 square plus x2. When you take everything to one side and taking common, you will get x1 equal to x2. Therefore, this will be a 1 to 1 function. But checking for onto, y equals x square plus x. Now, if you put y as 2, you will get x square plus x minus 2 equal to 0. The value of x, when you solve and get, it will not be belonging to integer. So this is not an onto function. We got our answer as option B, since it is 1 to 1 and onto function. Now next question, the greatest integer function f of x equal to greatest integer x is. They are asking whether it is 1 to 1 function or many one function. So checking for 1 to 1, I am taking f of x1 equal to f of x2. I need to see whether x1 equal to x2 or not. So I am taking an example of f of 2.1, means greatest integer of 2.1, which is equal to 2. Greatest integer means the first integer to the left of it in the number line. Left of 2.1 is 2. Now f of 2.9 I am taking. Greatest integer 2.9, which is equal to 2. The first integer to the left of 2.9 is 2. So I got greatest integer 2.1 equals greatest integer 2.9. But 2.1 not equal to 2.9. F of x1 equal to f of x2, but this x1 and x2 are not equal. Therefore, it is not 1 to 1 function. It is many one, because 2.1, 2.9, 2.5, 2.6, all these are connected to 2. Many of the elements are connected to 2. Therefore, it is many one function. Option B is our answer. Now, next question, the function f a to b defined by f of x equal to 4x plus 7. X belongs to set of real numbers is 1, 1, many one, odd, even. You know what is 1 to 1 function and many one function. Odd function means if f of minus x gives you minus f of x, then f of x is odd function. Even function means if f of minus x is giving you f of x, then f of x is even function. Here we are checking whether it is 1 to 1 or not. F of x1 equal to 4x1 plus 7. F of x2 is 4x2 plus 7. Equating f of x1 and f of x2, 4x1 plus 7 equals 4x2 plus 7. From here, cancelling the 7 and then cancelling 4, you will get x1 equal to x2. Therefore, it is 1 to 1 function. So our answer is option A, 1 to 1. It is not odd function because f of minus x will give you minus 4x plus 7. It is not negative of f of x. It is not even function because when you substitute x as minus x, you will get minus 4x plus 7. You are not getting back the f of x. So it is not even function also. So only option is 1 to 1 function. Now next question, f from real number to real number. This first real number is the domain and the second real number is the codomain. F of x equals 1 if x is greater than 0. Its value is 0 if x is equal to 0. Its value is minus 1 if x is less than 0. They are asking whether it is 1, 1 or onto or many one function. So I am checking for 1 to 1 or not. F of 1 is what? If f of 1 means x is greater than 0, so you have to take this value as y 1. F of 2, 2 is greater than 0, so your answer will be 1. So you got f of 1 equal to f of 2, but 1 not equal to 2. F of x1 equal to f of x2, but x1 is not equal to x2, therefore it is not a one-to-one function. Not one-to-one. Now checking for onto. For being onto, codomain and range should be equal. What is your range? Whatever you put for x, your y value will be only these three. So this is the range 1, 0, minus 1. But what is the codomain? Codomain is given in the question. This R. Both range and codomain are not equal. Range not equal to codomain. Therefore, it is not an onto function. So, what is the option? Many one. So, it is many one function. Option C is our correct answer. Now, next question. Let A equal to set 1, 2, 3, B equal to set A, B, C, and F equal set ordered pair 1, A, 2, B, P, C be a function from A to B. The value of P for F to be 1 to 1 and on to is. Clearly you can see 3 is not having any image. If 3 has an image, then only it will be a function. So P should be equal to 3. Now see, when you substitute P as 3, it will become 3, C. Will it be 1 to 1? Yes. And will it be on to? Yes, because range and codomain are equal. Codomain is set A, B, C. Range is this A, B, and C. So P's value should be 3. Option C is our correct answer. Now moving to next question. Consider the following for functions f1, f2, f3, f4. All these 4 arrow diagrams are given. They are asking which one are onto. You know the condition of onto. Range and codomain should be equal. Here range is A, B, C, D. Codomain is set A, B, C, D, E, F. They are not equal. Here range is set B, C, F. The connected y values are range. And codomain is A, B, C, D, E, F. They are not equal. Here range is set A, B, C. Codomain also set A, B, C. They are equal. So F3 is an onto function. Now checking F4. Codomain is A, B, C, D and range connected y values which are set A, B, C, D. Range and codomain are equal in F4 also. So F3 and F4 are onto functions. So our option is D. Correct answer. F3 and F4 are onto functions. Now next question. Let A equal to set 1, 2, 3 and B equal to set A, B, C. The number of bijective functions from A to B are. Options are given. This question I have already explained in my another video. Easy way to find number of different kinds of functions. Number of bijective functions, number of surjective mappings, number of injective mappings. Various conditions I have explained in that video. Now if number of elements in A and number of elements in B are equal, then the formula is n factorial. N is 3. 3 factorial, which is 6. Option C is our correct answer for this. Now coming to the question of the day. Let n of A equals 4 and n of B equals 5. The total number of all possible injections from A to B is. Option A 9, option B 24, option C 120, option D none of this. Send the answer to this question to the email mathswithanoop@gmail.com. No need to send any steps or anything. Just write the correct option, either A, B or C or D. Just send the email with the correct option, either A, B, C or D, mentioning your name.